Alright, today we're going to talk about our last form of a linear equation, which is point-slope form. We've talked about two forms already, slope-intercept form and standard form, and now we have point-slope form, which as you'll see today is kind of like a transitional form. We mainly use it to convert it into something else, usually slope-intercept form. So this is point-slope form, which is kind of set up funky, but all it talks about, as you might expect, is if you have a point and you have a slope and you know that they form a straight line, we can come up with an equation from that. So the x1, y1 means we just have a specific point that we're talking about. So there's x1 and here's y1. Those come from here, a specific point. So it could be 3, 2, 4, negative 2, anything like that. And then m obviously is still just going to be the specific slope that goes with it. I will prove to you why this formula works in class, but I'm not going to do it now just to save on time. So, what does an equation in point-slope form look like? Well, let's find out. That's what this particular example is asking. So write an equation in point-slope form for the line with the given slope that contains the given point. So we know that this point is on the line, and we also know that the line will have this slope. Well, we just plug in things where they should go. So my slope is 5/2, and we're going to fill in the rest here. So my specific point is negative 3, 0. Here's my x, here's my y, and specifically x1, y1, you can just remember that it's xy coordinate, right? So y minus 0 equals 5/2 times x minus negative 3. And here's what it turns into. For the purpose of leaving it in point-slope form, I am going to write y minus 0 equals 5/2 times x, and a minus and negative turns into plus 3. And here's my equation in point-slope form, which is ready to be converted into any other form that we've talked about. And I'll show you what that looks like coming up here. So that is point-slope form. And we could leave it just like that if all they wanted was for us to leave it in point-slope form. Okay. These particular examples, now they want us to take an equation and convert it into slope-intercept form. And if you have a slope and you have a point, you can do that. We've seen how to do that a different way, but now that you know point-slope form, this might be a little bit easier. So we're going to plug in what we know here. Alright, so it's going to be y minus my y value equals my slope times x minus my x value. And remember now the minus and negative turns into plus, so really we have y plus 2 equals negative 4 times x plus 1. And to turn it into slope-intercept form, I'm going to solve for y. So I'm going to distribute that. Negative 4 times x, and negative 4 times positive 1 is a negative 4. And now to solve for y, I'm just going to subtract 2 on both sides. And here we go. We got y equals negative 4x, negative 4 minus 2 is negative 6. Now we are in slope-intercept form. So the red equation and the green equation are the same thing. One's in point-slope form, one is in slope-intercept form. Interesting, right? And we could go ahead and convert that to standard form if we wanted to. So if we wanted to convert that to standard form, it's not asking us to, I would just add 4x to both sides. And now this equation is the same as the green one and the same as the red one. So we've got 3 forms: point slope, standard form, and slope-intercept, sorry. So slope-intercept, point slope, and standard. Alright, last example I'm going to go through here. And if they want you to figure out the slope-intercept form of a line given 2 points, there are a couple ways you can do this as well. But you do need a slope. Remember that slope equals y2 minus y1 over x2 minus x1. So maybe I do 2 minus negative 4 over 3 minus 1. Or 2 plus 4, which is 6, all over 3 minus 1, which is 2, and 6 divided by 2 is 3. Okay, well, now I know my slope, and I have 2 points that I can work with. So whenever you have a point and a slope, you can take those two things and plug them into our formula, y minus y1, our point slope form, and do this. And you can choose whatever point you want. They're both on the line, so they're both going to work. So my slope is 3, and I'm going to do y minus 2, that's my specific y value, x minus x1, which is 3, and then we just solve for y again. So I'm going to do a little distributive property, 3x minus 9 equals y minus 2, and then I add 2 to both sides, and we've got y equals 3x minus 7, and there we are in slope-intercept form at that point. So, all right, that is all I have for today, and we'll talk more about this tomorrow. So, we'll see you then.